Oops. 1 second here, sorry. Perfect. Once this comes back up, hopefully, there we go. Excellent. All right, let's go ahead and get started. So as I usually like to do, I've got some pretty basic review questions up front that we'll talk about, and then we'll do some practice problems a little bit later on. We're going to focus mostly on recursion today, so that I think was the biggest topic that we presented to you. Not the only topic, but the biggest topic that we presented to you this week. So what is recursion? Can somebody give me a quick definition of what it means for something to be recursive? Yeah, go ahead. When a function calls itself, exactly. So I have a function definition, and then somewhere inside of that function, I'm going to see a function, that function calling itself. That is recursion. Now, we can't just do that anywhere we want. We can't just do it whenever we want. There are certain restrictions, there are certain things we need to keep in mind if we're going to be performing recursion. So what are the necessary pieces of recursion? What are the things that we need for recursion to be successful? Yeah. So we need our problem to get smaller and smaller and smaller, right? The reason for that, yeah. No, go ahead. We need a base case. So that's actually what I was heading into. The reason that we need our problem to get smaller and smaller and smaller is because we need to have some sort of guarantee that we're eventually going to hit a base case, which means what happens when we hit the base case? We just stop, right? We just end. It's over after that point. And so we have to guarantee that we're eventually going to hit that base case. If we can't guarantee that, then we run the risk of a recursive function that just sits there and spins forever and ever and ever and ever. We don't want that to happen. We don't want infinite recursion to occur. All right, good. Let's talk a little bit about some compilation kinds of things before we do some practice problems. So who can tell me what a header file is and what it's used for? Yeah. Yeah, so it's sure, yeah, that's a great way of putting it. Like a toolbox that lets us know what kinds of functions we're going to be using in our code. Exactly. Yeah. And so if I want to use a header file, what do I have to do with it? I've got this beautiful header file, now I want to use it. So yeah, you have to include it. Yeah, you have to include it at the top. So we've actually been using header files. We just haven't been using header files that we've written. We've been using header files that come with the C standard library, for example, or header files that Harvard has written for CS50. But up until this point, we haven't been doing much with our own header files. That's going to start to change after today. We're going to start writing our own header files and including them in our own stuff. What's a compiler? Somebody tell me what a compiler is? This is something that's near and dear to my heart. Yes? Translates from one language to another language? Yeah, that's actually a great definition. So what are the languages we're using in this particular class? We're translating from what to what? Yeah. C to assembly, right? Where assembly is really just binary. It's a disguise for binary, right? Computers speak binary. It doesn't matter what programming language you start with, eventually it needs to be in binary for the computer to be able to understand it. So most compilers' main task is to take whatever language you care about, C or Java or JavaScript, whatever it is, and turn it into binary. That's the task of a compiler, right? What is make? What is make? We've actually been using make since the beginning, right? But yeah. Does everything. What's everything? Yeah, so it manages the compilation process, right? That's sort of its job, is to manage the compilation process. Exactly. What is Clang? Clang's another tool that we've seen actually since day one. Compiler, yeah, sure. Absolutely. So these are tools. Make is something that we're going to get a little bit more experience with when we do use the studio today. And also, you're going to see it pop up. I can't remember if it's on this problem set to be for sure. I feel like it is, but it's definitely on problem set 4. So you're going to see makefiles and other compilation kinds of things start to show up here pretty soon. All right, great. So what I wanted to do first today is go over the solution to Fibonacci, which was a practice problem that we asked you to do as part of our prep work today. I actually have the solution already written up in my IDE. So that's what I'm going to do. That's what I'm going to open up first. Here's my solution. Let me make it big so we can actually see it. Okay. And so your solution may differ from this. That's perfectly okay. Up here at the top, I just have some tests. So Fibonacci of 5 and Fibonacci of 10. Oh, my screen went out. Nice. 1 second. Let's see if we can get it back here. It should come back. Maybe. There we go. Cool. Sorry about that. So up here at the top, we have a main method that simply tests this function with a couple of small test cases. So give me the 5th Fibonacci number, the 10th Fibonacci number, and print those out on the console. I'll run it in just a second to show you how it works. But here's the function itself, and this is a recursive definition. So we just talked about what recursion needs in order to be successful, right? And the two things we said was it needs a problem that's getting smaller and smaller, and it needs a base case. So where are those pieces in this particular example? Where's the base case? What am I looking for when I say base case? If, right? So actually I have 2 if statements here, if n equals 0 and if n equals 1, right? So I have these 2 if statements here, and if I hit any of these values, you notice that I just return whatever I want the answer to be. So the first Fibonacci number, n equals 1, the Fibonacci value is 1. The 0th Fibonacci number, right, the answer is 0. So I just basically hard code in a couple of known values, right? I know what the answer is for these simple cases, so I'm just going to put those in and use those as my base case. Then we need the recursive step, and this is where things get a little bit complicated. Here, in this particular problem, I've actually kind of got 2 recursive steps. Do you see that? So I have 2 calls to the same function, Fibonacci, one for n minus 1 and one for n minus 2, which makes sense in this particular problem. In fact, you might hear this referred to as the recursive substructure of the problem. If I want Fibonacci number n, how do I compute it? If I say, give me the 10th Fibonacci number, you're gonna do what? Yeah. Right, we're going to get the 9th Fibonacci number and the 8th Fibonacci number, and we're going to add those 2 together, and that gives us the 10th Fibonacci number. That is exactly what this code is saying, right? So if n is 10, this says go out and find the 9th Fibonacci number, and this says go out and find the 8th Fibonacci number, and then we add them together, and we use that as our result. So what's going to happen? Let's assume, I have an example of 5 here. I'm going to step through the debugger with this one just to show you how this actually behaves when we run this program. So let me go ahead and debug this. So here I am on the very first function called the Fibonacci. Fibonacci of 5. So I want the 5th Fibonacci number. Let's go ahead and step into that function. And the first thing we're going to do is check our base case. Right? We always want to check our base case first. We always want to check our base case first. But the value of n, I should be able to see that over here, is 5. So my base cases do not apply, right? They don't apply yet. So if we continue stepping through, we see the base cases both fail, and we jump to our recursive step. And so now if I step into, where am I going to go? What's the next line that's going to execute? What's going to happen when I click step into? Where am I going to go? I'm going to go back up to the top, and I'm going to start this whole thing over again, right? The difference is, will n still be 5? I hope not. I hope not. N will not be 5. Let's take a look. We see that n is 4, right? We see that n is 4. So we repeat this whole process over again. step through, our base cases still fail. We get to our recursive step, and I step into, and we see n is now 3, and eventually n will keep decreasing, and we'll hit one of our base cases. Now n is 1. Look at the stack up here. This is actually what's called the function call stack. You can see that it's taken us 1, 2, 3, 4, 5 trips through Fibonacci to get here so far. It's taken us 5 trips through this function before we finally hit the base case. But this time, if we step through, we should hit the base case. It's going to give us back a value of 1. So where am I going to go after this statement? Where am I going to go? I heard, what did you say? The previous call. So the previous call was the one where n was equal to 2. I'm not going to go all the way back to n equals 5. I actually have to go all the way back up, right? I have to go all the way back up through each one of these first. So when I hit step, you see I'm actually at the end of one of these recursive calls because I figured out the answer. I figured out what it is. And so now I'm climbing my way back up. You see n is now 2, n is now 3, 4, 5, etc., right? Oh, and we finished. We eventually finished. I went a little bit too fast there, sorry about that. But down here at the bottom, we should see our results of 5, which I believe is correct. Right? So how does a recursive call work? We go all the way down to the base case, but then we have to go all the way back up through all of those function calls that were created on our way down to the base case. Right? That's an important step. Are there any questions about this process before I ask you to write some code examples of your own? Yes. 3, 0, 1, 1, 2, 3, 0, 1, 1, 2, 3. 0. So it starts with 0. 0 is 0. 1 is 1. 2 is 1. 3 is 2. And then I'm getting confused already. 4 is 3 and 5 is 5. I'm pretty sure this is right. In the back there? Fibonacci of 1 is defined as 1, which is what I have here, right? Yeah. Yep. Yeah, I know. It's a little confusing because we bring 0 into the mix, which just throws everything off. But I think it's right. Thanks for asking though. Yeah. Yeah, so what is going on when we go back up the stack? Well, when I say return, where do I go? What happens when I hit a return statement? Where do I go? Where do I go? Yeah. Well, I guess I'm looking for more generic terms. Listen, whether it's recursive or not, whether a function's recursive or not, when I hit a return statement, where do I go after that? Yeah. We go back to where the function was called. So when I'm doing things recursively, like in this example here, how many times did I call this guy? 5 times we just saw, right? I called it 5 times. So when I return, I'm going to go back to the one that's at the very bottom, which is then going to return to the one that's above that, which is then going to return to the one that's above that, and above that, and above that. So the return does not get to skip all of those and go back to the top. It has to go back to the one that called it, which is then going to go back to the one that called it, which then goes back to the one that called it, and work its way back up the chain, right? There is no shortcut that takes me immediately back to the beginning. I know it's a little tricky, yeah. Without the use of a loop? Well, I'm actually glad that you brought loops up, because recursion and iteration, for our purposes, at least so far, can be used to accomplish the same thing. In fact, we could have very easily rewritten this. In fact, I might have even asked you to do this in a previous course with a loop. I could have easily asked you to do this with a loop, and it would have been a pretty similar process. Maybe not exactly the same as what we see here recursively, but the act of remembering those previous 2 values, adding them together to create the next one, that's still the same. So anything I do iteratively, anything I do with a loop, I can also do recursively, which is a very important point that I wanted to make in today's class. But to go back to your original question, how does this keep going without the use of a loop? We're really using function calls. So instead of thinking how many times is this going to repeat, well, now you can think of that as how many times is this function going to get called. That's our iterations. That's our iterations now. In fact, these conditions here, these if statements, kind of remind me of a loop. Which kind of loop do they sort of match well with? These match up particularly well with a certain kind of loop that we've seen. That wasn't the one I was thinking of. I was thinking of a while loop. Recursion and while loops mesh very well together. Not to say you couldn't do it with a for loop. You certainly could do it with a for loop. In fact, anything you do with a while loop, you can also do with a for loop, right? So there's a lot of overlap there. But recursion is using a function call to get that repetition. Recursion is using a function call. Here, when I see n minus 1, right, that's kind of equivalent to having a for loop that says n minus minus as the increment piece, right? These base cases are the conditions, the stop conditions for my loops, right? When I define my input here, that's pretty similar to defining my loop variable in a loop. So all the pieces are basically there. Comparing these to loops is a very good way to learn how recursion works, actually. Any other questions before we try a coding example? So, since we're on the topic of loops, actually, I want you to write a function, but if you notice, the function that I'm asking you to write here, gosh, this thing is just awesome. There we go. Yeah. There we go. Okay, cool. We're on the wrong slide. There we go. The first exercise that I want you to do today, I want you to write a function that computes the length of a string, but I don't want you to use this existing string length function. Right? And then notice down here, I'm asking you to do this without recursion. I want you to do this without recursion, which might seem a little bit curious, but we are going to do recursion, I promise. I just want you to do this with a loop first. I want you to use a loop to solve this problem, and then we're going to solve this problem using recursion. So this is your first exercise, and I'm not going to just toss you in. Let's start this together. Let's at least create some tests that we can use and define maybe some pseudocode for this function before I throw you in there. First thing I need to do is create a new file. I don't have anything for this yet, so I'm going to create a new file. I'm going to call it strlength.c. Okay. And I'm probably going to need those includes at the top, right? So I'm probably going to need standard IO, probably going to need string, and I'm probably going to need CS50, right? The first thing that I like to do is create some tests. I don't want to create the function first. I want to create some tests so that if I get the function right, I know that it's going to work. So I'm going to create a little main method. And inside this main method, I'm just going to create some tests. So we'll say strlength, and we have to give it a string. So let's just try a couple basic strings. Sure, those are good enough. Those are good enough. Okay. And now let's talk about this function a little bit. I need to define it. So let's make sure we all start with the same function definition. What's the first part of my function definition? So I heard somebody say string. So types are good. What does the type represent? Return type. So what's the return type of this function? It's an int for a length. Then comes the name, right? String length. And then what comes after that? The inputs, which in this case, it's just a string. We can call whatever we want. String s. Okay? So here is our basic function definition. And before I ask you to write this, let's do some pseudocode. We can't use the strlen function. We can't. I'm banning that function for today, at least until we're done with this session. So how am I going to accomplish this instead? For loop, I'm actually going to use a while loop just because I'm going to be stubborn. Just because I'm going to be a stubborn guy today. So I'm going to use a while loop. I'm going to say while what? When do we know that we're done? Yeah, we have that null terminator, right? So while I haven't hit the end of the string, right? While you haven't seen that null terminator, what are we going to do? We're going to count up one, right? There's some other stuff that we need, like where's the variable for counting up? I didn't declare that, stuff like that. But this is basically it. Is there anything I'm forgetting? So then at the end, right, we're just going to say return the counts, right? So we're just going to count up one letter at a time. Count, 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 and then when we're done, just return whatever that count value happens to be. All right, I'm going to turn you loose. I'm going to turn you loose on this problem. I'll give you, I don't know, 5-10 minutes. We've got mentors around who can help you out if you get stuck. While you're working on this, I want you to kind of in the back of your mind be thinking about recursion, because, spoiler alert, the next thing we're going to do is we're going to write this recursively. So I want you to use a loop this time, but kind of have in the back of your mind how do these parts match up with the recursive definition of this function, right? Take a few minutes and we'll go through the solution in just a little bit. Alrighty. Not quite finished, that's all right, but I would like to start piecing together this particular solution. So who can tell me what's a good first step here in this function? What should I do first? Should declare a variable, we call it count, and what should it be? 0, right? Okay. Now, if you decided to ignore me and use a for loop, that's fine. I'm not worried about that, but I am going to use a while loop here, right? I am going to use a while loop. So, while what? What's my termination condition? While s count, right? So while the character that's at my counter's position does not equal that terminator character, right? What is that? \0. While that character is not the null character, then I just want to do what my pseudocode says here and count up 1, right? So I'm just going to say count plus plus. And then down here at the bottom, it says to return the count. Are we good? Yes? I don't believe so, no. I don't believe that they are equivalent. The question was, is that the same as typing in this? And I do not believe that they are the same. But you could always test it and see. I know this will work. I am not certain that using null there will work. Any other questions? So I want to, yeah, question. Trying to use is alpha on this. So the fact that this is coming in as a string, this input is a string, right? So will this ever not be alpha, I guess is my, I didn't give you any parameters in terms of what the string contained in this particular case. I'm not sure that is alpha is going to help us much here. Yeah. I also don't know what is alpha is going to do when it runs into that. That could cause a problem. I don't know what's going to happen when is alpha runs into that. My guess is it's not good. Any other questions or comments? I made a couple mistakes. I'm waiting for people to call me out on them. Yeah. I forgot the prototype. Yeah. Got the prototype. What else have I done wrong? I misspelled Sterling. Well, I didn't even intend to do that, but I did indeed. I did indeed misspell Sterling. Yeah. 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 These function calls are beautiful, but if I run this, what am I going to see? Nothing. I want to print these out. So let's print these out. That one I did do it intentional, I promise. Should be an integer, right? So D will work. Do the same thing here. All right. Close paren. Thank you. The compiler would have been happy to tell me about that one in just a second. All right. I think we're ready to test this out. Let me bring up my terminal here and see. Do I have a terminal? Oh, perfect. Perfect. Let me just make sure I'm in the right folder. Sterling. There it is. I see it. So make Sterling. And based on the tests that we have, hello has 1, 2, 3, 4, 5 characters, and bye has 3 characters, right? So hopefully I see 5 and then 3. So let's try it out and see what happens. Let's try this out. 5 and then 3. I think we're good, right? I think we're okay. So this solution, I think, works pretty well. Solution works pretty well. Are there any questions? So this was just kind of the appetizer. This is kind of the warm-up for what I really wanted to get to, which is recursion. So now that we've done this iteratively, I want to do it recursively. What are the parts that we need to worry about with recursion? Base case. So what's a good candidate for a base case? This guy right here. That's a great candidate for a base case. In fact, we can definitely reuse that as our base case, right? What's the other part of recursion? So base case is one piece. What's the other piece that we need for recursion? The function call that calls itself, and we need our problem to get smaller, right? Our problem to get smaller. So that might be a little harder to see in this particular example, but it is still there. What's dragging us towards the base case? What is it about this problem that drags us towards the base case? Which part of this code is moving us in that direction? Count. Count is moving us towards the end, right? As count goes up, as long as my string doesn't go on for infinity, which it can't, I will eventually hit the end of this string, right? Because count is just continuing to go up, right? So our recursive call is probably going to, what, increase count? So I can still have some idea of what count is, right? And then I can just increase it by 1, just like I'm doing here. And then eventually I know that that will lead me to this base case condition. I'll tell you what we're going to do. Let's try and make sort of a pseudocode example for this recursive function. I'm going to turn you loose on it, see if you can figure out how to code it up. So I'm going to create a new file. I'm going to do a separate file. New file. I'll call this one stir length. I'll put a big capital R at the end just to indicate that's the recursive version. You're, of course, welcome to call it whatever you would like. And some of this code is still pretty good, right? I can actually borrow this, right? I can borrow this stuff and reuse it. So instead of having to type all that out again, ideally, I want it to behave the same way that this does, right? I want to be able to give it the word hello and have it spit out the number 5. I'm going to put the R on the end there just so that I remember this is the recursive version of the string length function. And so, you know, ideally the prototype is the same, the function definition is the same. It's just the stuff that's inside the function that's a little bit different. But wait a second, we have kind of an issue that we need to deal with. Does anybody see sort of an impending doom that's coming up? So what do I want to do here? I typically, yeah. Mm-hmm. How do we count back down to 0? So I don't think we're counting down. I think we're counting up in this example. Like our previous example counted up, right? Am I misunderstanding? I feel like I might be misunderstanding your question. Here we're counting up, and our recursive function is also going to be counting up. I'm sorry? Yeah, so how does count fit into this? That's kind of the problem. Let's think if I want to make a recursive call that increases the count by 1, what does that look like right now? How do I increase the count by 1? Count, I mean, I don't have it yet, but I could say, you know, okay, count equals 0. That's what we did last time, right? We said int count equals 0, right? And then the next time around, I can just say, you know, string length s, but just make sure that count is increased by 1. What's the problem with this? It's just going to go back to 0, right? It's just going to go back to 0 because I've defined it as 0, very first thing. So count is never going to go up. It's never going to go up, right? Did you have a solution? Sure. Pass it into the function. So if I want to pass information from one function call to the next, we have a great way to do this. We can include it as an input to the function, right? But I want to be a little bit careful. I'm actually going to leave this untouched. I'm actually going to not do this. What I'm going to do is create a second function. I know we're getting a little crazy up here, but I'm going to create a second function. You can even call it string length R2 if you want to. And this function I'm going to have an int for count. So let's pause for a second and think about what that means. What do I do in this function then? Why did I put the second one in there? What does this function become? I want this function to just kick it off. So what is count at the very beginning? 0, right? Count is 0. So what I'm going to do is say string length R2. I'm going to make sure that count starts at 0. And then what am I going to put in for the first value? S. I'll just pass S along, right? I'll just pass S along. So what have we done here? We've actually just given us a chance to start count at 0. Now you might be asking me, you might be thinking, I feel like somebody might be asking me, why do we need the second function for this? Why couldn't we just put int count on the end of this function and call it a day? The reason for that is if I did that here, that changes how I call the function up here as well, right? That changes how that function behaves, because I have to start count there, right? I have to give it counts. I want this function, I don't necessarily want people to know this is a recursive function or an iterative function that uses loops, right? I want it to behave the same way, whether it uses loops, whether it uses recursion, no matter how I decide to solve the problem, I want it to behave the same way, which means the only thing it's going to take in is a string. That's it. Right? If I need extra stuff to track where I am, I can create extra functions. This is a very common way of doing things. This guy right here, this very simple basic function, has a special name. It's called a helper function. It's called a helper function. If there's anything in a recursive solution that only needs to happen once, that only needs to happen one time, whether that's at the very beginning or at the very end, then I can use a helper function to do that solo stuff. And then I could use this function down here to just do the recursive part, to do all the recursive stuff, right? If that's confusing, well, bear with me for a second, because hopefully once we code up the rest of this solution, it'll make a little bit more sense. Are there any questions right now before we? So the next thing we're going to do is code up a little pseudocode for this. I'm going to turn you loose on it. Is there any questions before we do that? Yes. Can I make a global count variable? Yes, but those of you who know me at all know that the word global coming out of my mouth is like, ugh. I just don't like global things at all. So can you do that? Yes. You will never see me do that. I do not like using globals if I can avoid it. And in this case, I can avoid it. Yes. Yes, we do. Absolutely. Thank you for bringing that up. Thank you very much. I do have to prototype that, just like we prototyped the first one. Absolutely. Absolutely. Any other questions before we start pseudocoding this recursive function? Okay, so pseudocode for this guy. We already talked about what the parts of the recursive function are. What am I going to do first in my recursive function? What's the first thing? Base case. Base case is always first, right? Base case is always first. So what's my base case? If I haven't hit the, or let's see, if I am at the end. So if I'm at the very end of the string, I'm all the way at the end, I've hit that null character, what's the length of that particular string? Or what's the answer that I should be giving back at that particular point in time, rather? Not necessarily zero. Well, you could get back 0. I actually see there's a potential fork in the road here that we could take, right? Consider, if I'm at the end of the string, what's the value of count going to be? That's going to be the length, right? So if I want to give back the length of the string at that point, it's as easy as just giving back count, correct? Return count. Okay, if I'm not at the end of the string, so else, what do I want to happen? I want to increase count recursive call. I'm going to leave this a little bit vague because this is kind of what I want you to think about, right? It's kind of what I want you to think about. This pseudocode should get the job done for us. Again, like last time, I've made a couple mistakes along the way that nobody has pointed out to me yet, but don't point them out just yet. See if you can figure them out while you're working on this. Again, I'll give you another 5 or 10 minutes, and then we'll talk about the solution. Alrighty. Let's see if we can piece this one together. Got this pseudocode up here. The first thing it says is if I am at the end of the string, right? So clearly I think I need an if statement. But what am I going to use to say if I'm at the end of the string? What's this condition going to be? We've already got it, right? In fact, I'm just going to come back here and borrow this, because that's exactly why I had you write this iterative version, is so you could refer back to it when you're writing the recursive one. This termination condition worked for the while loop. It'll also work for our recursion. So I'm going to go ahead and grab that and just use that exact same condition here. You see our pseudocode then says that if this is true, we should, well, actually, let's be careful. Almost exactly the same. I almost made a mistake. Something needs to change. Equals, yeah, instead of not equals, so it's actually the opposite. There we go. So if I have hit the end of the string, then my pseudocode says, quite simply, to return count. And then we have this else down here that says increase count, and then we need a recursive call. So what am I going to put down here? Somebody help me out. What do I need to type inside of this else statement here? Yeah. Count plus plus, that's a good way to start. Okay. And then what? What am I going to do? I need a recursive call, so what does that mean? Yeah, I see a hand. Can you say that for me one more time? I didn't quite hear you. You said something about S of count. Our function name, right? R2 and count. Okay. So we definitely have a recursive call here, right? This is recursive because I see that it's calling itself. So that is, in fact, recursion. I think this is a pretty good call, actually. So, I'm sorry, what was that? Just erase this and put return. I like this a little bit better. In fact, this brings up another issue that I wanted to mention while we were working on this today. If I declare a return type of a function, I always have to return an integer as part of that function, which means that no matter which path I take, I have to give back an integer. So if I take this return statement off, this is a very tempting thing to do, right? If I take this return statement off, I am violating that rule. Because if I go to the else statement, I'm not returning anything. And the compiler will let you know that you violated that rule. So by declaring a return type here of int, I always have to return an int. But what's the int that I'm returning? So it's an int from a future version of this recursive call, right? Just the next. And so what's going to happen? Eventually count's going to go up. I get the answer that I want, and then count is going to go all the way back, right? All the way back. I think this is it. I think this is good. Yes? Yeah, great question. What did we return from our helper function? So far, nothing. Waiting for somebody to notice that. So I can just put a return here, right? Just put a return here. Again, if I declare a return type here, if I say anything except for the word void here, I have to return something of that type inside of this function every single time. So you have to think about your if statements, right? If there's ever a path through an if statement that does not return an integer, in this case, I'm violating that rule. Question? Did I see a question somewhere? No? I'm imagining it. We haven't tested this yet. That's coming up very soon. Are there any questions about this? I do want to run this through the debugger as well, actually, and show you how it works through the debugger. So are there any questions before I do that? Yes? On which? Colots? I don't know. One plus. For this one, or I'm confused. I'm sorry. One of the follow-alongs. I remember sigma. Is that the one you're thinking about? Line 28. So we could, I mean, we could do this, right? This is an alternative solution. Yeah, this is an alternative solution, for sure. But well, I think I know what you're talking about. So I haven't tested this yet. I'm dying to test this to make sure that it works. Let me test it and make sure it works. I think I know what you're asking. I will come back to that, but let me make sure that this one works before I screw it up. So let's make stir length R, correct? And I got an error, all right. So what did I do here? Control reaches end of non-void function. Did I save? Yeah, I probably didn't. Thank you. Thank you. That worked much better. And now let's try, I should see the same answers that I saw last time, which are 5 and 3, right? In fact, I do see those. So I've created a function in two different ways, one that uses a loop and one that uses recursion, and they've accomplished the exact same thing, right? That was one of my goals today, was to show you that recursion, iteration, loops can be used interchangeably. So when should you choose one over the other? Does anybody have any idea of when you should choose recursion over iteration or iteration over recursion? You may have a feel for that. I guess so, yeah, go ahead. Only if you have a base. I mean, I think all loops, though, do have a base, right? All loops have to end eventually. All loops, we don't like infinite loops, so everything has to end, yeah. Mm-hmm. Yeah, merge sort, though, can also be done recursively quite easily. Here's an idea. So we haven't quite gotten to some of the advanced data structures that we're going to see in modules 4 and 5, but eventually we're going to introduce you to this concept called a tree. You've already sort of seen a tree when you think about binary search. We didn't call it a tree, but it's really there. So you know, we can use recursion very naturally with those kinds of structures. For the most part, though, at least up until the stuff that we've done up until now, if you're ever doing a problem like we've been doing and you're saying, should I do this recursively or iteratively, the answer is usually going to come down to, well, which one do you like to do? How do you feel about this problem? Some people just look at a problem and they think more naturally in a recursive manner. Some people look at a problem and they think more naturally in a loop, in an iterative manner. Neither way is particularly worse than others. There are some cases where recursion is in fact better, and as we get into module 4 and 5, you'll see some of those cases. There are some cases where iteration is in fact better. In fact, we've seen one of those today. Somebody asked about this on Piazza not too long ago. Fibonacci, while a classic recursive problem, I feel like is actually a better fit for iteration, to be perfectly honest. I've got a duplication here, right? The Fibonacci of n-1 actually contains the Fibonacci of n-2. So in some senses, I'm duplicating work that I've already done. With iteration in an array, I don't have to do that. So I think actually Fibonacci is a better fit for iteration, for loops, even though we solved it using recursion. So again, a lot of it's personal preference, but there are sometimes reasons to choose one over the other. All right, I was going to do something. What was I going to do? There was an alternative solution actually to this problem that I think you could implement, and I think this might go back to what you were asking me just a few minutes ago. If I wanted to, instead, I could think of this problem as being counting up each individual character one at a time, right? So instead of returning count at the very end, and passing that. Oh, I was going to debug this. That's what I was going to do. Let me do that first. I know I'm all over the place. Sorry. Let me debug this. I really did want to debug this and show you how it works. And then I'll go back to what I was thinking of. All right. So we are stopped on this first statement. I'm going to go ahead and step in. And you see, where do we go first? We go to my helper call, right? Our helper function. That should not be a surprise, hopefully. So then we step into this, and count, if I scroll down here and find count, which is right here, has a value of 0. That's exactly where we told it to start, correct? So my string is the word hello. So the first character is not the null terminator. It's actually H, the letter H. So my base case is going to fail, right? So I step over that, and I get to my recursive call. So I'm going to dive in. And now I see the count is now 1, right? Again, haven't hit my base case. Count is continuing to go up. Count is now 2. So I continue on, right? Count is now 3. Count is now 4. And then we should finally get to count of 5. So that's going to take me to this base case. We know 5 is the answer for this particular one. So that takes me to this base case. And so now I should hit it. And it says return count. So count is my solution. But again, take a look at what we've got up here. I had to go through this function 1, 2, 3, 4, 5, 6 times. Look, here's my helper function right up here at the very beginning, right? That's my helper function. So this solution is going to get passed back through each one of these. Through each one of these. So let me show you that. I'm going to go a little bit slower this time, because last time I did a little bit too fast. So you see I finished this function. When I click step the next time, I see 1, 2, 3, 4, 5, 6 calls to str length of R2. When I do this again, I see 1 fewer. You actually saw it disappear. Okay? It just disappeared. So I click it again, and 1 more disappears. So I'm working my way back up through all of those calls, right? 1 more disappears. 1 more disappears. 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 And then finally we're finished, and we print out the results, right? So I have to work my way all the way back up. I think there's actually an easier way to see this, perhaps a better way to see this in action, that is an alternative solution to this problem, as a matter of fact. I'm going to change this just a little bit here, so that we can see this in action a little bit better. I know it seems a little bit redundant. In fact, it is. But take a look at what's happening now. If I hit the end of the string, I'm going to say return 0, right? So say that string has a length of nothing, because the null terminator technically has a length of 0, right? And then now what's happening, I'm going to take the answer that I get back, and I'm going to add 1 to it before I pass it back up. I'm going to add 1 to it and then pass it back up. This should get me the same results. Let me just double check and make sure that I didn't screw that up. Make sure that it actually gives me the same results when I compile and run it. And then I want to debug this one for you too and show you. So it compiles just fine, and I get the same exact results, right? I get the same results. Yes? At what point? Mm-hmm. Well, let me run it through the debugger and show you. Let me run it through the debugger. This is really what I wanted to do. Let me run it through the debugger and show you exactly how this works. So here we are at our first function call. I'm going to go ahead and step into it. Takes me to the helper, just like it's done before, right? Count starts at 0. And just like we saw last time, actually, it's going to behave very much the same as last time for the first half. So I haven't hit my base case, and so I'm going to keep counting up. You see count is counting up, right? So let's see if I can move this. Okay, there we go. So count is counting up, and it's going to continue counting up until I hit the base case, which should happen when count is 5, right? So far, nothing has changed. We've hit our base case. So if I take a look now, you see all of these function calls, right? 1, 2, 3, 4, 5, 6 of them. right? I'm returning 0 from the very last one, but I'm going to return to the previous function call. So watch what happens when I go through this next step. I hit the end of the function. You can see count is still 5. Now count is 4, and x is 0. So x got this 0 that I returned from my base case, right? So what am I going to do? I'm going to add 1 to it, and then I'm going to pass that back up. Pass that back up to the next one. So watch what happens when I step through. Count went down again. It's now 3, but x is going up. X is going up. Do you see that? So the function call got the previous value of x, it added 1 to it, and then it's going to pass it back up to the next function call. So I step through again. Count is now 2, right? X is now 2, so I'm going to add 1 to that and keep passing it up. And keep passing it up until eventually we see I add 1 more to this, and that gets me my answer, right? My final answer. So that action of going down to the base case, but then climbing your way back up from the base case to where you originally started, that's important. I feel like, working your way down the base case, a lot of people get that pretty easily, but it can be very tricky to think about how you then have to climb back up to where you originally started. I can't skip all those function calls. Another way of thinking about it is I have to wait for this to finish before I can do this. When I call this function, it literally means go off and do this thing and let me know when you're done. And then whenever you're done, I'm going to do this next, right? So I've got a whole bunch of these that are just waiting to be finished, waiting to be finished, waiting to be finished. And then I hit the base case, and then they all start falling down like dominoes. All right, now you're done. So the next one can finish, and then the next one can finish, and the next one can finish, until we get back to where we originally started. Any questions? Any questions? Yes? Is there a ceiling on the call stack? There is indeed. That call stack takes up space. So if, the ultimate ceiling is how much memory do you have on your computer. In practice, they put a limit on it. I know in some languages it's around 500. And if you really need more than that, you can actually change it. You can make it different. But a default is usually going to be somewhere in that ballpark. Yep, they do cap it. If you ever see, so Stack Overflow is a very popular website, right? If I start putting too much stuff in the stack, it'll overflow, right? That's where that comes from. Too many recursive calls. Yes? Uh-huh. Yeah, so I guess let's run through the debugger and see what happens. So this is, hang on, let me change this back, sorry. I didn't quite finish. That's what we had before, right? But change this to count plus plus. Let's run through the debugger and see what happens. Let's run it through. I'm going to save. And where'd my debug? Okay, there it is. Disappeared for a second. Not sure why. It's back now. Okay, so here we are. I'm going to go ahead and step into this. That's my helper function, right? I'm going to step into that. And I should not hit my base case. I see count is 0 right here. So I go ahead and I step through. And if I step into this one, I hope that count is going to increase by 1. So let's see what happens. Count did not increase by 1. It did not. So what does that tell us about plus plus then? That's an interesting, it's a very subtle distinction, but an important one. If I say plus 1, that happens, boom, right away. If I say plus plus, it tries to resolve the function call and then add 1 to it. That's too late. Plus plus count, yes. I believe that will fix the problem, but don't use my beliefs. Let's try it out. Right? The proof is in the pudding, as they say. So let's try debugging it this way and see if that gets our counter properly. So here I am in the helper. Here I am in the first one. Fails the base case, and now I see count has increased the way I expect it to. Yeah. So this means it'll increment before the function call takes place. Count plus plus means increment after the function call is finished, which is too late for us. Count plus 1 behaves more like this, right, than count plus plus. We've got about 5 minutes left. Are there any other questions? Any other questions at all? Yeah. What our helper function is doing for us? Sure. So in order for this to work recursively, I need this count variable, right? I need this count. I can't think of a way that I could do this recursively without having a variable to track where we are in the screen, right? So the helper function is really just doing the equivalency. If we refer back actually to how we did this with the loop, right? The first thing I had to do was initialize count to be 0. My helper function is doing that initialization for me. So when I think of a recursive function, I have to think that function's going to sit there and loop. It's going to repeat over and over and over again. If there's anything that I don't want to repeat over and over and over again, then I can use a helper function to do that one-off stuff, which is what we're doing here. It's the same thing for a loop. If I don't want stuff to repeat, then I move it outside the loop, right? If I don't want stuff to repeat in a recursive function, then I move it outside the recursive function into a helper function. So it's really kind of a similar concept to that. Another advantage of doing it this way is that imagine I gave this function to somebody else. Would I want them to have to specify what count is? Probably not. I always want count to start at 0. So by using this sort of middleman, it allows me to, treat this function in a much simpler way. I just give it the string and it figures it out. Whoever is using this function doesn't have to know that there's this extra thing called count that starts at 0. They don't have to know that. That's not their problem. They just have to give me a string, and then the helper function takes care of setting up everything else behind the scenes, right? So that's kind of 2 reasons why I like using a helper function here. But the main moral is if there's any stuff that I don't want to be repeated in the recursive function, then boot it out to the helper function. Create a helper function and do the stuff that only needs to happen once goes in the helper function. Stuff that's going to get repeated goes in the recursive function. Any other questions? Other questions? Alrighty. So what we're going to do today is, I realize that we've got people working on different stuff. We've got a studio for you to work on today, multiplication and exponents, which focuses on recursion. I know there's people who are still working on earlier studios in Module 2 or whatever. And so we would like to try and help you find somebody that's working on the same stuff as you. So if you would like a partner to work on whatever it is that you happen to be working on at this moment in time, we are going to try and help people find like-minded individuals to work on studios together. Up here at the front of the room, there's going to be some mentors up here to help make those introductions happen. So if you're interested in finding somebody to work with, come on up this way, and we will do our best to help you find somebody to bounce some ideas off of. All right? Cool.
Do we want to get the classroom folks out here too?
Potentially.
Kind of, so like help work things at the end.
I'm thinking
We
maybe.
just want to let them be in there and then just do whatever out here.
Yeah, so
Oh, I need to cut my audio.